Hi, algebra students. We're going to be continuing our work with solving inequalities. Today's lesson is on compound inequalities. I'm going to go ahead and start the presentation. Let's try that again. I want to share the screen. So let's do this a sec. We can do it. There we go. Anyway, hopefully we can see this here. Display from start. There we go. So you'll need a piece of paper for today's warm-up. So go ahead and pause the video and try these problems on a piece of paper. Okay, welcome back. So we're going to be solving these inequalities and graphing the solution on a number line. So I'm going to grab my pen. And our first one, it looks like our first step is to subtract 3 from both sides. That gives me a negative 9m is greater than or equal to negative 18, right? Both signs are negative, so I add and keep the same sign. Next step, divide both sides by negative 9. And remember, when you multiply or divide by a negative number, you need to reverse the inequality. So my answer is going to be m is, and not greater than or equal to, but less than or equal to, and negative 18 divided by 9 is a positive 2. All right, our next one, looks like we have some like terms we can combine on the right side first of all. So I'm going to rewrite the right side of this inequality as 6 minus x, because 5 plus 1 is 6. And on the left side, I have 4 minus 2x. So I'd like to get the like terms together. So I'm going to go ahead and add x to both sides. I could have done several things. I could have subtracted 6. I could have added 2x. I could have subtracted 4. So I just made the arbitrary decision to add x to both sides, but you could have started in a different place. So that gives me 4 minus x, because negative 2 plus 1 is a negative 1, is less than 6. All right, I now have my variable on the left. So I'm going to subtract 4, which will give me all my constants on the right side. I'm going to move over here because I'm running out of room. So now I have negative x is less than 6 minus 4, which is 2. One more step. I'm going to divide both sides by negative 1 because I need to end up with a positive x. So negative divided by negative is positive. Again, because I'm dividing by a negative number, I need to reverse the inequality from here to here. And so my final answer is x is greater than negative 2. All right, let's go ahead and look at today's information. You have one definition to write down in your journal. On page 50, let me move me here. It's kind of hard to see this. On page 50, it says the definition of a compound inequality is two inequalities joined by the word and or the word or. So go ahead and open your journal to page 50 and copy down that definition. In the notes section on page 50, please copy down this information. It says this inequality would be read as x is greater than or equal to negative 3 and less than 3. So the solution, you're going to see a compound inequality where you're going to have parts of a number line marked, and there's going to be either two endpoints like this, or it could be the inequality, excuse me, let's go back a slide, is going to be going two different directions, or it'll be a combination like this one is. So notice we're looking at values that are less than 3 or greater than or equal to negative 3. All right, so after you get that copied down in your notes, let's look at the next slide. So we're going to jump right into some extra practice problems. So the first one is asking me, and this is extra practice number 1 on page 51, It's asking me to represent an inequality that is a number u that is less than 7 and greater than 3. So I'm going to put the numbers 3 and 7 on my number line. So here's 3, 4, 5, 6, 7. And I'm going to go a little bit past in each direction. And if you have room, you can do this same thing. All right, so it says a number u is less than 7. So I know I have an open circle at 7, all right? And values less than 7 would be going to the left. And greater than 3. So numbers greater than 3, I need an open circle at 3 and an arrow going to the right, which means that all the solutions are any number that lies in between 3 and 7. So 4 would work, 5 would work, 6 would work, so would 4 1/4 or 5.25 or 6 3/8. Anything in between those two values is a solution. All right, extra practice number 4 says a number C is more than -4 or at most -6.5. So I'm going to put these numbers on my number line this time. So I've got -4, -3, -2 this direction, and -5, -6, -7. I'll put a couple more in there. So this time it says it's an or situation. So let's see what happens when the compound inequality contains the word or. It says a number C is more than -4. So if it's more than -4, we're going to have an open circle at -4. And our arrow is going to be going to the right. And it says, or it's at most a -6.5. Well, -6.5 is in here. And it's saying it could be at most that. Notice it can't be these two things at the same time, which is why these inequalities have the word or. So either we're going to be considering numbers that are less than 6.5, or we're going to consider solutions that are greater than -4. So hopefully you can see me in the video. So I like to think of and inequalities as going like this. And if it's or, they're going like that. The arrows point out. Let's look at our next slide. So a solution of a combined inequality joined by and is any number that makes both inequalities true. So extra practice number 6 says, solve the inequality and graph the solution. So remember we talked about the fact that and when we see one like this says 4 is less than x minus 3 and less than or equal to 7. So I know this one, because this is contained between these two numbers, 4 and 7, my graph is going to end up looking like this. It's an and inequality. So these are kind of fun to work with. Here's your variable here that you're trying to get by itself. So that means I need to add 3. Now what you'll do is you will not only add 3 to get the x by itself, you'll add it over here to this part of the inequality, and you'll add it here. Okay, because remember, whatever we do to one side, we have to do to another. Well, in this case, you actually have 2 inequalities, so it's like 2 sides you have to deal with. So that moves our 3 from the middle. On this side, we have 7 is less than, we have our x by itself. And on this side, we have less than or equal to 10. So this says my solution is any number that is less than or equal to 10, and it has to be greater than 7. So all the numbers in between 7 and 10, including 10, because it has the equal sign. So I'm going to put those numbers on my number line. There's 7, 8, 9, 10, and I'm going to go a little bit past in each direction. I follow the same rules as before. Because this is just greater than, I put an open circle at 7. For 10, I'm going to have a closed circle. And this says my solutions are greater than 7 and less than or equal to 10. which means it's anything in between these two, including the 10. Okay, so that's why I say the and is pointing in, because my solutions have endpoints. It might be an open circle, but they have endpoints and they are connected in the middle. All right, let's look at another example. Okay, extra practice number 7 says solve 15 is greater than or equal to negative 5g and it's greater than or equal to negative 10, right? Again, this is an and problem. It's kind of an implied and. Let's grab a pen here. Whenever it's kind of smushed all together like this, I like to think of it as being an implied. I don't know why we've stopped writing. There we go. An implied and, because it's in between the two values. Okay. So I just realized I put that right where I need to write. Let's see if I can get the eraser here. Let's do this. Well, I know what I can do. I'll just go back. I'll go forward again. All right. So this is and. I'm going to grab my pen. And I need to get g by itself. So to get g by itself, I need to divide by negative 5. And remember, with these, you divide everything by that value on both sides. And there's 2 sides, so it's actually 3 places I'm dividing by negative 5. Because I'm dividing by a negative, I have to remember to switch the inequalities, and I need to switch both of them. So 15 divided by negative 5 is negative 3. It's less than or equal to g. That gets my g by itself. That's what we were trying to do. And it's greater than or equal to negative 10 divided by negative 5 is 2. Oop, I forgot to switch that one, didn't I? Okay, have to remember to switch, otherwise it's not going to make any sense. All right, so this says my solutions are any value less than or equal to 2 and greater than negative 3. So let's put those on the number line. We've got negative 3, negative 2, negative 1, 0, 1, 2. And I'm going to do a couple more each direction. Not much room on this side. All right, so close circle at negative 3, because my solutions are values that are greater than or equal to negative 3 and less than or equal to 2. So close dot at 2. And the solutions are all of these numbers in between negative 3 and 2, including negative 3 and 2. All right, let's look at the next slide. So it says a solution of a combined inequality joined by the word or is any number that makes either inequality true. So on or inequalities, the solution can't happen at the same time. It either has to be one or the other. So an or inequality will end up looking like this, where you have 2 arrows facing out and there's going to be a gap in between the 2 of them. So let's look at this one. So this is in your journal on page 52, extra practice number 8. So when you have an or inequality, you go ahead and solve each inequality. So on this first one, I have z plus 4 is less than 2. So I'm going to start out by subtracting 4 from both sides. All right, so one of my solutions is z is less than negative 2, or, and I need to solve the other one. In this case, I divide by negative 3, and I have to be careful. I'm dividing by a negative, so I have to remember to reverse the inequality. So z is, instead of being less than, greater than 9. And if you notice, a number can't satisfy both of these. It can't be both bigger than 9 and it can't be less than negative 2. So that's why we have the word or. It's got to be one or the other, because there isn't an overlap in between these two. So let's see if I have enough room on my number line. Probably not. I might have to go by 2s. So I'm going to make this negative 4, negative 2, 0, 2, 4, 6, 8, 10. All right, so this says z is less than negative 2. So I put an open circle at negative 2. Values that are less than negative 2 are to the left. So my arrow's going to the left on this side. Or I'm looking for solutions that are greater than 9. So 9 is halfway in between 8 and 10. So I'm going to do an open circle at 9. And my solutions are going to the right in this case because its number is greater than 9. So if you notice, there's no overlap. The arrows are facing outwards in this OR inequality. All right, extra practice number 9. It's another OR situation. So I solve each inequality separately. I start with this one by subtracting 6 from both sides. I have 2t is less than 10 minus 6 is 4. Divide both sides by 2. And I have t is less than 2. All right, let's solve this one. I subtract 7 from both sides. That gives me negative t is less than or equal to 2 minus 7 is negative 5. To get t by itself, I divide by negative 1 on both sides because I want a positive t. And because I've divided by a negative, I need to remember to reverse the inequality. So negative divided by negative is positive. So my solutions are values of t that are either less than 2 or greater than or equal to 5. So I'm going to put those numbers on my number line. 2, 3, 4, 5. I'm going to go a little bit to the right and left of those numbers. Right? So to graph this side, I have t is less than 2, open circle at 2. My solutions are to the left, all values less than 2. And my other inequality, I have t is greater than or equal to 5, so a closed circle at 5. And solutions that are greater than or equal to 5 are to the right. Again, notice when you have an OR inequality, your arrows are facing out. They aren't overlapping. Your assignment today is the compound inequality card sort, and the link to this activity can be found on today's agenda. So good luck, and you can ask me questions in class if you have any, or shoot me an email.